Hi, in last video we were revising integrals. So what we're going to do now is to consider different applications of integrals into economic problems. The first one that we're going to consider is how to go from marginal function to total function. Look, this problem appears in economics over and over. And look, the best example would be marginal cost. Look, marginal cost is the cost of producing one more unit. So this is the cost of producing one additional unit, right? I hope you remember that in your microeconomics classes, if you wanted to obtain marginal cost from total cost, all you had to do was to differentiate total cost, because this is the information you get from the derivative. What happens if we increase production? Talking about derivatives, of course, we mean by a very small amount, but in economic interpretation, it would be one more unit. So from marginal cost, we see how total cost is growing or declining, and it's usually growing. Okay, so look, in other words, we can say that marginal cost is the first derivative of total cost, right, with respect to quantity. Okay, so now let's consider an economic problem. Let's just say that marginal cost is given by 2e to the power 0.2 q. Okay, we will be using integrals to find total cost. But right away, we should notice something. Look, if we perform integration, what we are left with is a function and an arbitrary constant that we need to definitize. So for this, we need to have some extra condition, usually we call them initial conditions. And in our case, we will assume that fixed cost is equal to 90. Look, why fixed cost is so useful over here? Look, fixed cost is the cost of production that is not associated with the level of production. This is the cost that is associated with everything that it's not actually directly used in production. So if level of production increases, this cost doesn't change. So this would be rent for a building. This could be accounting services. This would be lawyer services. This could be cleaning services, right? But now we can use this information to get the full total cost function. Okay, so what do we need to do? Look, I think it should not come as a surprise that we're gonna calculate an integral of marginal cost, of course, with respect to quantity. Okay, so let's do it. I'm going to do it slowly. Probably when you will be practicing it with Valeria, you will have to do it a little bit faster. But now let's do it. Let's do it step by step. Okay. So now we have an integral of 2e to the power 0.2 q dq. And look, every time when we want to integrate an expression with e, what we want to have over here is derivative of the exponent. If I differentiate the exponent with respect to q, I'm going to get 0.2. So I want to have 0.2 over here. So now, what I need to take out of the integral to have 0.2 here? Well, this is very easy here. Well, I need to just take out 10. Right? Because 10 times 0.2 is 2. So everything checks out. Okay, so we can continue and we get that this is 10 e to the power 0.2q plus c. And look, this is only halfway done because we have this arbitrary constant, something that we just discussed, and we can get rid of this arbitrary constant using a fixed cost. And look, I know this is very tempting to do it like this. So if fixed cost is a given number and c is also some number, why not replace it? And look, in various economic applications, this is exactly what you need to do. But this is not true all the time. But there is always a way that can assure us whether this is going to work or not. Because look, we know that on one hand, total cost, if we produce 0 units, is equal to fixed cost. And fixed cost is 90. But look, we can also do the very same thing with the expression we've got over here. Because this is expression for total cost, but of course it gives us a family of different possible answers because we have not definitized c. Deuce form. So, look, we can also calculate that c of 0 is 10 e to the power 0.2 times 0 plus c. And of course, look, 0.2 times 0 is 0, e to the power of 0 is 10. So look, we've got that this is 10 plus c. Okay, now, because those two expressions, of course, must be equal, we can compare them. So we've got that c plus 10 equals to 90, and consequently, c is equal to 80. And now, we have found the total cost function. Because now we can simply substitute for c over here and we get that total cost is equal to 10 e to the power 0.2 q plus 80. Okay, now let's try something macroeconomic. From macroeconomics. Okay, now, I hope you remember NPS. NPS is marginal propensity to save. Marginal propensity to save is telling us how much out of one additional dollar households spend on savings, right? So again, if this is additional value and we have word marginal, we can calculate it simply by finding the derivative. So look, in other words, marginal propensity to save is going to be first derivative of savings with respect to income. Okay, and let's say that our NPS is equal to 0.3 minus 0.1 y to the power negative 1 over to the power negative 1 over 2. And also, we need to have a definitizing condition. So we can definitize our constant, so we need to have initial condition. And look, this time we're going to use a slightly different condition. Look, let's just say that we know that if income in our hypothetical economy is equal to exactly 81, then savings are 0. And I think still this is enough for us to find savings function. So, and this is what we're going to do. Now, having marginal propensity to save and this additional condition, we will be able to find savings function quite easily. Okay, so we need to again differentiate income, MPS with respect to income. And so how do we do? Look, okay, this is very simple case of integration. Here we will have 0.3 y, and now minus, okay, here we have y to the power 1 over 2 divided by 1 over 2, right? And dividing by 1 over 2 is like multiplying by 2, so we will have 0.2 over here. And of course, as usual, we have definitizing. We have arbitrary constant. Now, so in order to again get total savings function, we need to use this condition to find c. Okay, so look, because this is already calculated, we can simply substitute 0 to savings function and 81 to savings function, and what will we get? Look, here we will have that this is 0.3 times 81 minus 0.2 times square root out of 81 plus c. Right, 0.3 times 81 is basically 8.1 times 3, so this is 24.3. Then over here we will have square root out of 81, of course, is 9 times 0.2 will give us 1.8. And of course plus c. Okay, now we get out of this that this is equal to 22.5 plus c. But of course, look, we also know that level of savings, if income is 81, is equal to 0, so we can conclude that 22.5 plus c equals to 0. And from this, we get that c must be equal to negative 22.5. Okay, so finally, our savings function can be written as 0.3y minus 0.2 square root of y minus 22.5. Okay, and let's stop for a second and well, the answer is definitely correct, but let's discuss some finer points of this result. Does it make sense? Look, first, if income is 81, we get that savings are 0. This actually informs us that at some relatively, let's just say, low level of income, people cannot afford to save, which makes perfect sense. But now look, in this case, if I'm substituting 0 for income, on the other hand, this is 0, this is 0, this is 0, we get negative result. So can savings be negative? Of course, they can. It's called dissaving. Imagine if you do not have any income, the first thing you need to do is to use your saving to finance your current consumption, because otherwise you would die. Okay, so now let's go back to microeconomics examples. And in these microeconomic examples, we're going to use marginal revenue. Okay, so now we've got marginal revenue, and again, look, marginal revenue is first derivative of total revenue. Marginal revenue is telling us how much more money the company is going to make if it produces and sells one additional unit of a good. Okay, so definitely this is a first derivative of total revenue. Now, let's just say in our hypothetical example, the total marginal revenue function is given by 10 times 1 minus q to the power negative 2. And this time we're going to do one more complication. I'm not going to give you any additional information at the beginning. We will have to figure out how should we definitize the constant on our own. Okay, but let's start with more mechanical thing. If I want to go from marginal revenue to total revenue, of course what I'm going to do is to integrate total revenue, marginal revenue. Okay. So we've got that this is 10 times 1 minus q negative 2 dq. Okay, so look, in this case, integral has become a little bit more complex. So what we need to do over here is definitely use integration by substitution. Okay, so how do we approach this problem? Okay, so look, we need to set up some u. In this case, we clearly see that this is the most problematic part. So let's just say that u is 1 minus q. In this circumstance, du dq, so first derivative of u, is simply negative 1. And look, when we use integration by substitution, what we want to have is to have derivative of this function inside, so negative 1 over here. What do I need to take out of the integral to have negative 1 over there? Well, I need to take negative 10. Negative 10 times negative 1, what gives us 10? Okay. Okay, so now we are ready. So let's start substitution. We've got negative 10 integral. Instead of this, we can put du dq. Instead of this, we can put u. So we will have u to the power negative 2 dq. And look, of course, those two expressions cancel each other out. So what we have is a simpler integral du, right? So now we can easily calculate this simpler integral. We will have that this is negative 10 times u to the power negative negative 1, right? Because we will have plus 1 over here, and we will be dividing, and we will be dividing by negative 1, right? So here we are dividing by negative 1. Right? So we clearly see, of course, plus c. So clearly we see that those minuses cancel each other out. So what we end up with is 10 u to the power negative 1 plus c. Okay, so now we can substitute back for u, and this will give us 10 times 1 minus 10 times minus q to the power 1 to the power negative 1 plus c. Okay, so we've done this first part, the mechanical part. Now we simply know. Now we simply know that in this case, in this particular case, this is the function that we need to use, right? So how do we proceed? Okay, now we need to definitize the constant. So we've got that revenue. We need to ask ourselves when total revenue is equal to 0. And look, total revenue is, in other words, total revenue is price times quantity. So it means that total revenue can be 0 only in two circumstances, right? It's either if P is equal to 0 or if Q is equal to 0. I'm using or over here because, of course, if both are 0, well, of course, total revenue will be 0 as well. But look, in this case, we shouldn't assume that that price is going to be 0, right? Because we are assuming that our company is selling goods at some price. So in this circumstance, total revenue is going to be equal to 0 if and only if quantity is equal to 0. So look, we get out of this that total revenue out of 0 is equal to 0. Okay, let's proceed. Knowing this, we can easily definitize our constant, right? Because in this we can simply take this expression, right, and substitute 0 for q. Okay, so we get that, or maybe I'm gonna do over here, that r of 0 is going to is equal to 10 times 1 minus 0 to the power negative 1 plus c. This, of course, is equal to 1. 1 to the power negative 1 is still 1. You get that this is 10. Okay, and look, now we get that 10 plus c. So we get that 10, comparing those two expressions, we've got that 10 plus c is equal to 0. So we get that c is equal to negative 10. Okay, so look, our final answer in this case is that total revenue is given by 10 to the power 1 minus q to the power negative 1 minus 10. Of course, look, this total revenue function is not maybe very economically accurate, but the entire process that we went through is 100% correct. Okay, look, I think that this, what we said this far, should tell you everything you need to know how to approach different economic problems where we have some marginal function and we need to get the total function. Remember, when we have total function and we want to obtain marginal function, it's easy. We just calculate derivative, right? That's it. Here, we've got a two-step process. First, we calculate the integral, and then we either use some information we've got, or we need to create a condition that will help us to definitize the arbitrary constant. Okay, so thank you for your attention, and in the next video we will be continuing tackling with different applications of integrals in economic problems, and we're going to talk a little bit about investment and capital formation.